Who has made a mistake? Softball. All right. Who has made a mistake in code? Something you've written like in text. All right, that's the best kind, right? Who has deployed that mistake to production? Guilty. Who doesn't want to make mistakes again? That's easy. All right. So you're my target audience. That's perfect. People who don't want to make mistakes, you know, it's like 100%. Well, it's a Venn diagram, but whoever's on the outside of the, I don't know. I don't want to talk about those people. So thank you again for coming, and thank you for PSU for allowing me to speak. It's really an amazingly well-run conference. And round of applause for everyone who's helping out with the cameras and everything else. It's really one of the pillars of the Mac admin community, so we're lucky to have that every year. I am Elliot Jordan. Just making sure, yep, you can see what I see. I'm from the security team at Nordstrom, and I am also a software developer. And I didn't used to say that with very much confidence, but then a few weeks ago, heard our friend Arjen, the developer of Monkey Report, put it very well. And after hearing Arjen say this, I'm a little bit more confident now. Like, yeah, I am a software developer. I do write and ship code. And the fact that that code supports operational systems and managing Macs, you know, it doesn't make it any less important or any less of software. So, you know, the career arcs of Mac admins are really arcing in that direction. They're moving ever closer to our cousins, the software developers and software engineers. We're writing more code in more languages. We're using APIs. We're maintaining open source tools. And some of us are even doing like unit testing and dependency management, which we're going to have to do even more in coming operating systems. So we're definitely becoming developers. And if you don't believe me, here's just a small sample of some of the code that you probably touch on a daily basis. And I would say, yeah, these are all code. You know, all these files are text files. And for decades, software developers have mastered ways of you know, editing, saving, managing, and arguing about text files. So I think they can definitely teach us a thing or two, or we can learn some of you know, some useful things from the intermediate area between IT and security and development. So as those two areas kind of diverge, it makes sense that a lot of the core concepts in the middle there are going to be some things that we have to learn. And the place where those things converge is often called DevOps. And that's definitely a buzzword. It is kind of overused sometimes, kind of like agile or, you know, cloud. But at its core, DevOps has some good stuff. It's about sharing and spreading good development practices to operational teams like IT and security. So there's a really good grain of truth at the core of that. If you're writing a lot of code to manage Macs or enforce policies or manage any computers really, you'll quickly see how some of these tools from developer land will be super useful to you. And after all, reducing errors and streamlining development and automating things are kind of universal goals. They're something that everybody in the world wants to do with their job, hopefully, and make their lives better. So that's what this is all about, right? We're going to focus mostly today on the first thing here, reducing errors, saving our bacon, so to speak. And it helps to know, in the context of what I'm going to present here, there are some ground rules, some kind of fundamental principles that I follow. And if you follow them, you may find that a lot of our needs and requirements align. If not, that's okay too. You'll probably find some useful stuff. But some of those ground rules include, for example, code standards. People who live and breathe in a particular language of code or a particular method of development know their tools best. And so I'm using tools like Pylint, for example, from the people who write Python day and night. And I kind of trust that the code standards that they've implemented are good ideas. And so I'm going to use code standards whenever possible. Git, everything in Git, or at least everything that touches production in Git. And I know there are other source controls out there. Git is definitely the most popular among Mac admins, and it's the one that I use, so that's the one I will be focusing on. But everything that you write that touches production belongs in a Git repo. And not just a local Git repo, but a shared collaborative Git repo, something that you can push to remotely and then pull from and share with your teammates. And that's going to give us some other features too, which you'll see a little bit later. Peer review, the idea that if you're making changes to the code in the repo, that somebody else should probably put their pair of eyes on that code for just a second, just to make sure that the changes you're making are good ones. This can be somebody else on your team, can be a subject matter expert, can be your manager, but just it's a good idea to make sure that a second pair of eyes is going to take a look at that code before it goes into the protected master branch. And this is an idea that I only started using recently, but it really works well with the Git workflow that I'll be talking about today. You lock down that master branch on your Git remote, and only branches that have been approved by your peers can be merged into master. I'll show you how that works. But these are the ground rules that we're going to use. If you already align with most of these, then you're going to love what I'm going to talk about. Or if you want to use some of these tools, then I think you'll find some useful stuff too. So, with that settled, let's talk about 3 specific DevOps tools that I would encourage Mac admins to embrace. And those are linters, Git hooks, and CI/CD pipelines. So we'll dive right in with linters. Linters are static code analysis tools that run on your Mac and alert you to syntax errors, logical errors, and small improvements that you can make in your code in real time. They're usually powered by a locally installed binary, plus a plugin for whatever text editor you're using that allows it to get the output from that binary and display little notes to you in real time as you type. The effect is very similar to spell checking. If you're used to, if you've ever worked as a writer of any kind and you've had an editor, that's very much the same concepts we're talking about here today. The spell check, the editing process, the proofreading, and then the sending to production. So what you see up there in Microsoft Word is very similar to what we're going to see in our code editor. And because linters happen as you type, they're very efficient. The feedback loop is very small. It's almost immediate. You can see their suggestions. You can adjust the code that you're typing, or you can ignore them if you don't happen to agree or if you want to come back to it later. It's very minimal cognitive load. It's not a lot of stress, And combined with the autofill features that a lot of text editors have in coding environments, it can be a really useful thing. You just start typing a couple letters, and out pops the properly linted code. So it really is minimal brain power needed to use linters, at least in the beginning. So one of my favorite linters is called Shellcheck. It's for linting shell scripts or bash scripts or whatever version of shell you're writing for. And one of my favorite text editors is Atom. So I'm going to show you how to combine the two, how to use Shellcheck in Atom. And I'm going to make a little bit of a shortcut here by assuming that you have Brew installed or that you don't mind installing Brew. There are other ways to install Shellcheck, and there are some valid reasons you might not be able to use Brew or might not want to. But if you go to shellcheck.net, you'll find the instructions for alternative ways of installing. But this is what I do. Brew install Shellcheck. Once you do that, then you can type which Shellcheck and see where it is in your path. Hopefully it's in your path if you've used Brew. For me, it's at user local bin Shellcheck. Just select that path, copy it, and we'll use that later. Now, assuming you've got Atom installed, pop open Atom, look at the preferences. On the left side, you'll see a button that says Install, and then type Linter in the search field. And you'll find a package that just says Linter. That is the base Linter plugin that a lot of additional Linter extensions kind of plug into and use and extend. So we're going to install that one, and it'll look like that. Then search for Shellcheck in that same search box, and you'll see one that says Linter Shellcheck. And install that package, and then click on Settings, because we're going to paste in that path that we got earlier right there, where it says Shellcheck executable path. For me, you may not need to do this step, but for me, I did have to put in that path explicitly because otherwise Atom didn't know about user local bin. I'm sure there's an Atom configuration that you could use as an alternative. Maybe I'm missing something, but this is what I did have to do for Shellcheck. So it'll look like so. The other box that you might want to check in here or uncheck is enable notice messages. These messages are typically not critical errors that Shellcheck is going to find. It's the very low severity stuff that you might not care about at first. So if you're just starting to use Shellcheck, I would recommend actually not checking this box quite yet. Get used to some of the more severe errors and the warnings and the errors. Take care of those first, and then come back and check this box later. But there is a lot of good stuff that this box will show you that you wouldn't otherwise see. If all of that goes well, when you open your next shell script in Atom, you should see this. You should see messages pop up, little squiggle color-coded things. If you click on those, you'll see the actual error that it's warning you about, along with an ID code and a link that you can actually click on, and that'll take you out to the Shellcheck wiki that will explain all the errors in detail. Very helpful. You can look up anything that it's telling you about and find out if it's important enough for you to take action on. Some Shellcheck messages appear red. These are the most severe or critical messages, and they have a higher likelihood of breaking whatever script you're writing. So this, for example, you'll see I made a typo. There's a parenthesis there that should be an underscore. So if we fix that, the red critical error goes away. It's replaced with a yellow kind of warning error or warning message. This suggestion is if you're going to CD to something in a script, you should have an exit plan. You should do pipe exit or something like that. Just in case that folder doesn't exist, you may not want to continue executing the commands in the rest of the script. It's good advice, so I usually do that. Other types of things you might see are deprecated syntax callouts. This is an example of a notice message that you get when you check that additional box. Really useful stuff, but it's not a deal breaker. If you use backticks instead of the parenthesis syntax, not a big deal. It's still going to work, but it might be a good idea to move into the future. And here's another one. Rather than checking the exit code indirectly by using $?, it suggests here if you're not going to use that value later, you might as well just check it directly. You can type if command, then do something. And if that command exits 0, then the then clause will be executed. So it's a little bit more direct way of executing the same thing. There's some good suggestions. I actually learned that from Shellcheck. I had always checked $? On every script that I'd written if I needed to do that. And Shellcheck was the first thing that told me, hey, you might think about doing it this other way. So it's a really great learning tool for things like that. Now, one of my favorites, useless cat. Rather than catting a file into grep, for example, you can grep that file directly. There's no need to bring two different commands into this. Same is true of a lot of awk grep stuff. There's no need to pipe grep into awk. Awk already has that functionality built in. So who among us, though, hasn't had a useless cat at some point? And yeah, like I said, Shellcheck is a really great learning tool. I didn't know some of the minor differences in the shells between POSIX shell and bash, for example. In macOS, it doesn't really matter because they're functionally equivalent. They're not quite the same binary, but they execute the same code just fine. So whether you put bin sh or bin bash at the top of your script, so far on macOS hasn't mattered very much. It probably will very soon in Catalina or beyond. And as you know, Z shell is going to be the default in Catalina, so that will have some implications. But for example, one of the things that I learned that were different between POSIX shell and bash is the double square brackets don't exist in POSIX shell. So if you declare bin sh as your shell at the top, you can't use the double square brackets. I like the double square brackets, so I usually use bin bash at the top of my shell scripts. And that makes that message go away. And like I said, Z shell is coming in Catalina, and unfortunately, Shellcheck does not yet support Z shell scripts. I hope someday that will change, but there is a GitHub issue about it on the Shellcheck GitHub page, number 809. If you want to go give it a thumbs up, express your support, I'm sure the developers would appreciate that. But I'm hoping someday that Z-Shell will be supported by Shellcheck, but right now that's not the case. So enough about Shell for now. Let's talk about Python. There's a great Python linter as well called Pylint. And you can also integrate this with Atom. I'm not going to step through the whole process, but if you search for Pylint in Atom, there's a Linter Pylint extension that you can install. And you can also install Pylint using pip. I think also maybe brew, but definitely pip. And notice here a little interface note. There's a small upward pointing arrow at the bottom of the screen here in Atom. And if you click on that, you'll see a list of all of the current linter messages. And this can be really useful if you have a very long file and you're not quite sure where the messages are coming from. You can actually click on that line number on the right-hand side, and it'll take you directly to the line that is at issue. Very useful. So let's actually walk through fixing a Python file that's having some linter issues. We've got an issue on this file, for example, right away on line 1. It says missing module docstring. And that's just trying to get me to adhere to rule, I think it's PEP 257, that says your Python module or script needs to have a docstring that explains what it does, as some very kind of basic built-in documentation for every Python file. It's a good idea, so I'm going to add a docstring up at the top there. Just a triple quoted string at the top underneath the shebang is all you need. Next, I've got OS, unused import OS. That's funny, because I thought I used that somewhere. Well, the next one says undefined variable walk. Well, it's not a variable. Oh, I see what happened. That's supposed to be os.walk. It's actually a function inside of that module that I'm trying to access. So if I change that to os.walk, those two messages go away. Next line, we've just got some minor spacing issues around the brackets, so we can tighten those up a little. And finally, at the last line, looks like bad indentation. Yeah, it looks like I only used 2 spaces to indent there instead of 4, so I'm going to add a couple more. There you go. Got a Python file with no linting issues, ready to share with the world or put into production or whatever after peer review. So as you use linters more, you'll find that sometimes they produce some false positives. Sometimes there's things that you just don't agree with. Sometimes there's things you want to come back to later, or that you just want to disable altogether. Here's one example that I usually disable. I learned, somebody raise your hand and correct me if I'm wrong on this, but I think Pylint does not load C extensions by default for security reasons. So that's why, even though I do have this module installed, as every Mac would, Pylint can't see it. So it produces a very severe message that shows me that it's going to fail, red lights, warnings, but it's actually not true. It's going to work just fine. Anybody nodding, agreeing with that? Yep, okay, all right, I'm not totally off base then. So this is a message that can be ignored. To do that, Pylint has some special declaratives that you can put in your comments, and that will ignore that particular issue for the whole file or for a section of the file, like so. You take the ID number that's being displayed with that message. In this case, it's E0611. And you put that into a comment that says Python or Pylint disable equals E0611. If you put that at the top of your file, Pylint will not warn you about that particular message or that particular warning or error, linting issue, for the whole document. And that can be very useful for kind of cleaning up the clutter and ignoring the ones that don't actually cause any harm. You can also use the long identifier. If you run that file through Pylint in the terminal, you just type Pylint and then the path to the file. It will show you the longer, kind of more readable name for that error code. And you can put that in the disable command alternatively if you'd rather have something more readable. And you can also comma separate if you want to disable multiple of these warnings. You can just separate the IDs by commas or separate the longer name by comma. If you don't want to disable that particular issue for the whole file, you can wrap the code that you want to turn it off and then on again with these comments, like so. It'll just ignore that error between those two declaratives. Or you can disable that message just for one line by tacking the disable message onto the end of that line. Shellcheck has the exact same capabilities. You can ignore errors. For example, this one I know is not going to be an issue because I'm controlling the input, so I'm never going to get rmrf/ is what it's worried about me trying to produce here. It's a valid concern, but I know that's not going to happen here. So I can add shellcheck disable equals SC2115. It's the ID code of that particular error. That disables it for the next line. That's the way that shellcheck works. It's a little bit different than Pylint. But like Pylint, I can also add that message at the top of the file and disable that message for the whole shell script. So as great as linters are, and there's really no reason not to start using them if you're writing a lot of shell in Python, there are some limitations. The biggest one is that they have to be installed and managed per Mac, not only per Mac, but per app on your Mac. If you're integrating them with your text editor, if you switch to a different text editor, that integration doesn't remain there. You have to install it once per text editor on every Mac on your team. So it's not something that can be easily distributable. There are some command line tools for Atom, for example. There's APM, Atom Package Manager, and you can use outset scripts and get very clever with the pre-installation of linters if you really want to, but it's a lot of hoops to jump through to manage for your team. And at its core, the linting suggestions are optional. There's nothing to force you to follow all the checks, at least not yet. We're going to get there. Let me take a little detour here and talk about linters' cousins, autoformatters. These are things like Python Black, YAPF, or YAPF. I'm not sure if you're supposed to pronounce that. That sounded wrong just now. YAPF. All right, sounding better. It's getting there. AutoPep8, isort. For Go, things like GoFormat. And for Ruby, Rubocop. These are linters, some of them. But they go a step further, and they actually give you the ability to automatically snap your code in alignment with its suggestions and enforce those suggestions, not just optionally choose to make them or not. You can run your code through these, and it comes out linted the other side. Python Black is one that I use almost every day, and this is famously, they even say it's uncompromising. It's famously opinionated. There is pretty much one Python Black style. There's very little configuration that you can do. And if you don't agree with that style, tough cookies. And I kind of like that. At first, that was really jarring, but I've gotten used to it. And the benefit of these tools, and tools like Black, are that you can basically stop worrying about the way that your code looks and just type it and worry about the function of it, the logic of it, and what it's actually doing. When you hit save, or when you run it through Python Black, it's going to come out the other end with the correct style. So you don't need to worry about style when you're actually writing the code. And that's kind of a relief. And it has stopped a lot of the discussions in our team of like, do we indent here? Do we use double quotes or single quotes? Like, that doesn't matter. It's been dictated from on high now that we're using Python Black. So here's just an example of a small section of an auto package recipe processor before Python Black. I went back in time and took a snapshot of what it looked like before it was blackened and after. I'll do the optometrist thing here just for a second. A, B, A, B. It's very subtle. It's not that different. But you'll notice that before, there were some single quotes for strings. I happen to prefer single quotes for strings. It's easier to type on an American keyboard. But There's also a little bit of differentiation between the indentation. Sometimes the strings that extend beyond, that make the line a little bit too long for our preference, have to be wrapped to the next line. And where you cut that line is kind of a personal preference. For black, it's less of a personal preference. It comes out the same way every time. So you notice a lot of the lines get kind of indented, maybe a little bit funny, not quite the way that you would have chosen, but it's the same every time. So it's, what's that word? Idempotent. Yeah, I like that word. You can run it through multiple times and get the same result. It's non-damaging to run it through multiple times. Did I say it wrong?
No, it's not that. I was just curious. It looks like there's more space between the lines. Can you repeat?
Yeah, he said it looks like there might be a little bit more space between the lines as well. I will say, here's before, here's after. Yeah, you're right. At the bottom, between modules, or between functions in a script, it will add 2 spaces. And between other things, it's typically 1 space. And yeah, that's a good call out. The nice thing, though, is that it does that every time the same way. So if it adds 2 spaces between your functions the first time, you can run it through again, and it'll remain the second time. It won't add any more space. If you start to use Python Black with like really nested parentheses, you'll notice that it really likes vertical space. It doesn't like horizontal space. It will eat up as much vertical space as it needs to make that parenthetical nest expand. And it can look really weird, especially if it's in an if clause. But it actually is not a bad idea, because when you change those, the things that are nested in the parentheses, you're much less likely to have a merge conflict if there's a lot of vertical space used, because each line is diffed independently. And that's an edge case. You know, if you have people changing the same conditional at the same time and then wanting to merge those 2 things back in, it's kind of unlikely most of the time. But Black does tend to expand vertical space a little bit more. So it looks a little bit weird at the beginning, but I can attest, you get used to it. It's not bad. The most jarring thing is that the first time you convert your code base to Python Black, you get a massive diff. Pretty much all the lines are going to change. And the end result of that diff is a functional nothing. If it went well, nothing should have changed. The code is doing the exact same thing. So it just makes it really especially aggravating to review if you're a maintainer that somebody submits let's say a massive open source project is being converted to Python Black. I don't know, maybe AutoPackage, for example. It's a lot of work to make that happen. And thank you, Nick McSpadden. We love you. Python Black is one of the steps that AutoPackage is taking to move into Python 3 compatibility, and it was a big help to have this tool, Python Black, to rely on. Because if we had to go through and check everything manually and make sure that it's Python 3 compatible, or to make sure that everything is indented the same way or all the strings are quoted the same way, it would drive a human insane. So that's what computers are for, and that's why I use things like Python Black. As with the linters, there are ways to turn off Python Black for sections of your document or for the whole document. In this case, you can just specify fmt format : off. And at the bottom, when you want to turn it back on, fmt : on. And this example is a field map that I use for a particular API that I'm kind of attached to the way it looks. I kind of like the way that everything aligns vertically very nicely. Eventually, maybe I'll get over that, and I'll let Python Black do its thing on that particular variable. But right now, I want to keep it a little bit longer. So I disable Python Black for that section. And as I kind of implied earlier, there are some reasons that you might not want to use autoformatters for a particular scenario. If you're just submitting a typo change or a spelling correction or a minor small little thing to a repository that doesn't already use Python Black, it may not be a good idea to go all in. It's going to generate a massive diff that confuses the developers and kind of buries your typo fix in a bunch of other changed lines. So maybe hang out in the repo for a little while and make sure that the maintainers are cool with changing their code style before you submit a massive diff like that. And there are some limitations as well. If, like I said, if you don't happen to agree with the style choices that Python Black is making, or some of these other formatters, then you're kind of out of luck. But I can say it's really nice not having to worry about the way that things look. It's, you hit Command S and you save, and it automatically just makes it the right style, and I don't have to worry about that anymore. And it's not easily distributable, like Linters, across a team of people using various text editors on various computers. But we can make it a little bit more distributable with some help from Git hooks. It's a good transition to our next section here. Git hooks are small pieces of code that can run when specific triggers are happening in Git. For example, when you commit, a pre-commit hook can be executed such that if that hook passes, your commit goes forward and everything happens as it normally would. If that code fails and the pre-commit hook exits non-zero, your commit doesn't go through. You have an opportunity then to go and fix whatever it is that the problem that was preventing you from being able to commit, and then try the commit again. And the benefit of that is that whatever it is that was preventing that commit from going through never even shows up in your Git log. As far as all the other team members know, you never made that mistake in the beginning. It never happened. So it really saves you from yourself a lot of the time. Pre-commit hooks and all Git hooks are natively built into Git. If you open any Git repo, there's an invisible .git folder already in there. And inside that, there's a hooks folder. And there's some templates in there that you can use to create your own hooks. And basically, you just exit 0 if you want to continue with whatever the action was, or exit 1 if you'd like to stop the action from happening and give the person a chance to fix the issue. That works pretty well if you're just managing your own repo, but you can't commit those hooks to the repo itself and share with other people, at least not easily. So there is a tool called pre-commit, not to be confused with the hook pre-commit. It's a framework for managing those hooks. And you can find it at pre-commit.com. It's multiple languages, it supports multiple languages, so you can write your hook in Shell or in Python or Ruby or whatever you prefer. And it takes care of installing the dependencies needed to run your hook, and it doesn't require root privileges or admin privileges. So it kind of eliminates a lot of the issues of managing Git hooks yourself and smooths it away. It lets you specify just a list of hooks that you want to run, and then basically forget about it. And every time you type git commit or commit in a text editor or in a Git UI app, it will run those hooks before it allows you to actually proceed with that commit. So let me do a quick little demo here. We're going to use brew again to install pre-commit. And then we can see where it's installed and what version. Unlike with Shellcheck, we don't need to copy that path. It's just kind of good to know sometimes. Once the actual pre-commit binary is installed, you can navigate to your Git repo and create a configuration file. This file should be called .pre-commit-config.yaml, Y-A-M-L. And in that file, if you want to open it up with a text editor, here's a very basic pre-commit configuration that you can start off with if it's your first time kicking the tires. This is a good one to start with. This hook is called no commit to branch, and it's in the repo with the URL listed up there. It's kind of the main pre-commit hooks repo. And this hook has one job. It prevents you from committing if you are on a designated branch, and by default that branch is master. Now recall, one of our ground rules before was a protected master branch on the remote. You can't commit directly to master on the remote. You have to make a branch and then get peer review, and a pull request is created, and then you can merge to master after that. What this hook does is essentially create that same restriction on our local computers so that we don't get into the situation where we've accidentally committed to the local master and we can't push because the remote master is protected. Once you save that configuration file, you do have to take one additional step, which is to activate the hooks. That reads that config file and puts the appropriate scripts in place in that invisible.git folder automatically so that you don't have to manage it yourself. But you do have to type pre-commit install. That activates the hooks in that specific Git repo, and you do have to do that once per repo on your computer. So let's kick the tires here. Let's test it out. Yes, sir?
Is there anything similar to like pip install R requirements for that workflow?
He asked if there's anything similar to pip install-r requirements.txt or something like that that would list all the requirements that are necessary. That's kind of what the configuration file does for the hooks. So once all the hooks are listed in the configuration file, subsequent installs of pre-commit will automatically use those hooks. And that's the point of the config file, is to distribute that configuration to the whole team. As far as installing pre-commit itself or activating the pre-commit hooks in the repo, there's no automatic way to do that as far as I know. You could write a setup.sh script and just have everybody run that once when they start committing to the repo. I do that for some other things because, for example, I have auto package recipe repo at my company locally that has a setup script that just automatically adds all the requirements, all the required repositories and everything else. So you could do that for pre-commit for sure. So let's try it out. We're on the master branch right now. And if we try to commit whatever we've changed, notice that you see a little bit of new output here. It's going to say, don't commit to branch, ... failed. So that test, that no commit to branch hook, has failed now because we are on the master branch and prevented us from committing. So now nothing has changed on our Git repo. Nothing has been saved to the log. We can have the opportunity now to go and fix whatever it is that it was complaining about and then try again. And in this case, we would just create a new branch. Git checkout-b pre-commit, or whatever you want to call the branch name. And then we can try our commit again. Passes. And everything else proceeds as normal. That's pre-commit in a nutshell. Obviously, that one hook is really useful, but you're probably going to want more. Especially if you navigate to that URL, you'll see there's a ton of hooks available just in that repository. And there's other repositories too, which we'll get to. But in that repository, there's 2 additional hooks that I can add in here. Check added large files. That prevents any file greater than the specified size from being committed to your repo. Typically, committing large files to Git repos is not that useful because the diff isn't going to give you useful information. You might make exceptions for things like icon files or small images that are used in README documentation. But overall, you wouldn't want huge files to be added to your repo. So this just gives you a way to actually enforce that. And check merge conflict. This ensures that all merge conflicts are resolved, and it doesn't let you commit any text files of any kind that contain leftovers from a previous merge conflict. It's saved me a couple times. In addition to the hooks that are available in the main pre-commit repo, there are also many, many other repos available with pre-commit hooks. This, for example, is our friend Python Black. There is a repository that stores a pre-commit hook that will allow you to run Python Black on all of your Python files while you do the git commit process. If any files are changed by being run through Python Black, the hook will fail. But then usually you can just try the same commit again and it will succeed because those files only needed to be changed once. If there's a fundamental issue with one of those files and Python Black couldn't process it, then it will fail again a second time, and you can take a deeper look at that. And you may be thinking, well, if we've already configured Python Black in our text editor, why are we also needing to configure Python Black in pre-commit? And the answer is you don't, It's just an additional redundant layer. And it's much easier to maintain Python Black as a requirement in your team or your organization if you add it to the pre-commit config. Because as I'll show in a minute, that configuration is manageable across your team. And it's something that's much more easily updated and changed and modified versus sending out a memo to everybody, please install your linters. It's not really scalable. So having Python Black installed in your text editor and having it as a pre-commit hook just makes it a little bit easier to manage and ensure that all the code that you're getting that's Python has already been blackened by the time you see it. So here's an actual working pre-commit file that I use for various Git repos. This contains a mix of scripts, Python, Shell, there's some YAML in there, there's there's documentation. So this checks for white space issues. It prevents you merging or committing to master, checks YAML files, checks symlinks to make sure that they're actually pointing to something useful. What else? Byte order marker, yeah. So the byte order marker is something that you get if you edit files on Windows sometimes using Notepad or other text editors on Windows, you'll get a byte order marker in that file. And if you want to eliminate those and prevent those from being committed, you can add that hook. So there's all kinds of hooks in there. Then some of them are useful and some are not. The nice thing is if the hook doesn't apply to the files that you're changing, it'll get skipped. Pre-commit only checks the files that are being added or modified under normal circumstances. So if you're not modifying or adding any files that apply to these hooks, everything just skips right through. Notice too that there's a rev or revision tag in each of these repo definitions in the pre-config YAML file, or pre-commit config file. This is basically just pinning your hook that you're running to a specific tag on GitHub for that repository. It ensures that you're running the same version of that hook every single time, and that all the members of your team are running the same version of that hook. You wouldn't want a bug in the hook to produce inconsistent results. So this kind of just locks you into a version of that hook. And there is a way to update those versions automatically if you want to get the latest versions of the hook. In your repo, you can type pre-commit auto update, and it will go back and increment all of those version numbers to whatever the latest one is on GitHub right now. And you may also notice in the config file that there are some additional options that you can specify. Args is the most common one, and that's basically just passing through parameters to the command line hook. It's saying, I want this value to be X, or I want this particular option to be enabled or disabled. For example, the max KB in the check added large file script, notice we can set it to 200 instead of 100, or whatever you want. 2048 would give you 2 megabytes. So the args are just configuration options for the hooks. And yeah, so as you can see, I've also added, forgot to mention this. At the end of my config file here, you'll notice that there's even a hook called blacken docs. This is really cool. It will actually run Python Black on any snippets of Python code that it finds in your README files. So not only do your Python files get run through Python Black, but little Python snippets you put in your documentation also get run through Python Black. Very cool. So there are some additional hooks out there. I definitely encourage you to go to pre-commit.com and then click on supported hooks at the top, and you'll see a list of literally hundreds of available hooks that you can use in your repositories. Probably only a dozen or so will be relevant to you, but definitely check it out. One of those is the pre-commit hooks for Mac admins. I created this a couple months ago just to make it easier to add pre-commit hooks that Mac admins might care about. These hooks include some auto package, monkey, and Jamf specific checks that you can run on your repositories. So let me walk through a few of those now. Here's a config file that you might use in a repository that contains package sources. For example, monkey package projects. And what this does, the first hook here, check monkey package build info, ensures that the build info file is actually a valid one and that certain issues are caught early. For example, if the version is not a string in that build info file, monkey package will fail to build that project. So it's just checking for little tiny mistakes like that. Probably not mistakes that anybody in this room would ever make, but just in case, you know, most of the pre-commit hooks that I made were because I found some way to mess something up, you know, and I thought, why not share that failure with the world and prevent others from suffering? You'll also see check outset scripts. If you use monkey package to produce packages that contain outset scripts, this is really useful because it will check to make sure your outset scripts are executable before it allows you to commit those to the repository. I can't tell you how many dozens of times. It seems like every single time I create a new outset script, I forget to make it executable, and then I wonder why it's not working. This prevents that from happening again. Never make that mistake. And check plist. It just lints your plist files, make sure that they're valid. Does what it says on the label. Here's a config file for public auto package recipe repository, like the ones you see on GitHub. There's a check-in here for auto package recipes, obviously. Checking to make sure the required keys for every auto package recipe are present. You can optionally specify a recipe prefix, and it will check your identifier of your recipe to make sure it starts with that prefix. Typically, that's something like com.github.yourusername, for example. For organization-specific recipes, it might be com.yourcompany.something. And it also checks that you are following certain recipe conventions that are generally good ideas. There is a strict option that you'll see up there. You can enable that only if you're a masochist. It is what it says. It's very strict. A few additional and very opinionated checks are run. Basically, me putting my own personal opinion into code, saying, no, you really should have an end-of-check phase processor after this URL downloader processor, for example. Those are not necessarily rules. They're just maybe a higher level of checking that you want your recipes to be held to. I don't know. But it definitely does not work for every recipe. There's some recipes that need valid exclusions from the strict checks, so you can choose whether to include that or not. There's a hook that forbids auto package overrides from being added. It does its best to determine what an override means. I think the definition that I'm using is, does the recipe contain a process or not? If it doesn't, I call that an override. As long as it has a parent recipe, then that's an override. If you have a public auto package recipe repo, you may not want to accidentally add your overrides to that repo. So this is a good hook to have. Same thing for trust information. That's not meant to be kind of shared publicly. It's meant to be used in an override locally on your computer or within your organization. Here's another config file for internal auto package recipes. This is very similar to the last one, except you'll notice the com.example.autopackage. That could be your company identifier prefix, for example. And there's another hook here, check auto package recipe list. If you use a recipe runner, some script that you've written that automatically runs auto package on a regular basis, this will ensure that that list that you're passing to it is actually a list, either YAML, text, plist, or JSON. And here's the most complicated one. This is my pre-commit hook configuration for my monkey repo. This includes some optional arguments that check package info keys that we require. Other organizations may not, but for example, category and developer, we require those to be present in the package info files that are submitted. If you don't have a version specified in your package info or a category, then pre-commit won't even let you commit that package info. And you'll see that in the error output. You can go back and add the missing key. The hook also checks for duplicate imports, as indicated by the double underscore suffix that would be added to the package name. And it ensures that an icon is present either by the name of the file .png or by specifying the icon name in the package info, and other minor issues too. So let's talk about pre-commits, one of pre-commit's strengths, which is collaboration. You've got a wonderful pre-commit config file that's working for you locally, and you want to share that with the other members of your team. So the way this works is you would just push that pre-commit config up to your Git remote, and on each other person's computer, they would have to run brew install pre-commit if they don't already have pre-commit installed. Then they would do a git pull to get the configuration file, and then pre-commit install in the repo to activate the hooks. They only have to do that once per repo, but they do have to do it once per repo. And you do that on each of your team members' computers. Once you've got everybody with pre-commit installed, hooks activated, config file present, then everybody runs the same hooks on every commit. It's very nice and clean. You can modify the hooks, push that newly modified configuration file to the remote, everyone else pulls it down, and then they start checking the modified hooks as well. It's wonderful, but there are also some limitations, of course. The pre-commit hooks that you see publicly, including mine, are typically written for a very broad audience. They're written to kind of catch the least common denominator issues. And they only include some of the most generally applicable checks. You may have more granular checks in your organization that you want to run, and pre-commit may not have an easy way for you to run those checks. Also, pre-commit needs to be periodically maintained. The revision tag that you saw earlier, running auto update it's not that hard, but it is something that you do have to do once in a while when you want to update the versions of your hooks that you're using. And fundamentally, pre-commit can still be skipped if somebody doesn't want to install the pre-commit binary, for example, or if they don't want to activate the hooks on the repo, or if they run git commit -n or -no verify. That will skip the git commit, the pre-commit hooks and all git hooks from happening. So fundamentally, it's not quite enforceable. But that brings us to our next tool, which, if it is set up properly, is enforceable, and that's CI/CD pipelines. This is one of the great reasons why we're using a git remote as one of our fundamental ground rules. Every bit of production code should be in Git. All of that Git code should be pushed to a remote with a protected master. So if we take a closer look at that Git remote, you'll see why we want to have that protected master. Many of the Git remote options out there, the Git hosting options, GitHub, GitLab, Bitbucket, all support some kind of CI/CD, or continuous integration, continuous deployment. And that's what we're going to be leveraging. Your code can be automatically linted and formatted and checked, and the product of that code, whether it's a package file from a monkey package project, or a profile that you need to be signed, or fully built monkey catalogs, can all be done in the cloud on your Git remote itself. And the master branch that's protected can run certain tasks that other branches don't, or they can skip tasks that other branches do run. So we'll get into that in just a minute here. Using Git remote automation to do the code inspection or the product build is CI/CD. And so when I say CI/CD, that's what I'm talking about. Continuous integration, continuous deployment. Some people say continuous delivery, and typically that would be for like a web app or something like that. For me, I think continuous deployment, because I'm deploying my code into my management tool of some sort. Some examples of the specific Mac admin tasks that might be useful in these particular phases of the pipelines are shown above. Oh, and I use the word pipelines because that's what GitLab uses, and I use GitLab. So most of my examples here will be kind of GitLab focused. But the CI/CD pipeline is made up of specific jobs that can run individual commands or individual scripts. And if any of those jobs fail, then it can optionally fail the pipeline. So that's how we're looking at it here. And of course, we're going to add peer review to make sure that before anything gets built or pushed into deployment, it's going to be looked at by at least 2 people giving a thumbs up. Yourself plus somebody else for the thumbs up. And you may notice that there are some more redundancy here. There's more added layers and safety nets. We're going to be using linters and autoformatters and potentially even pre-commit hooks in the pipelines too. So we're really tripling up on a lot of these tools, and that's okay. It's because unlike on the local machine where you've got linters that people may or may not have installed, pre-commit hooks that are great and distributable but not fully enforceable, unlike those, we can actually enforce all that on the Git remote. So on GitLab, getting started with CI is pretty simple. There's already great documentation about it, so I'm not going to duplicate that here. But in short, you need to install a runner. And for a lot of the jobs that I'm going to show today, it has to be a macOS runner because we're using tools like Plyutil and other stuff that only exists on macOS. So there is a GitLab, install GitLab runner on macOS documentation that is excellent. I suggest you follow it. And many MacAdmin CI jobs can and should be run on small, easy to manage Linux containers if you have a system set up for that. I'm lucky I do have a team that manages virtual, Dockerized Linux boxes that I can spin up and spin down as needed to run my CI jobs. But there are some jobs that I need, like Plyutil, that just need a Mac. So there is a Mac that I have installed the GitLab runner software on that I maintain myself. Once your runner's installed and registered with GitLab, you'll see something like this appear in the GitLab settings. This is a specific group. The runner can belong to a group, it can belong to an entire organization or a specific repo. There's varying degrees of specificity depending on what you need. Once the runner's installed and registered and working, then the next step is dead simple. You just create a configuration file that describes what jobs you want to run in your CI pipeline. And that file has to be called .gitlab-ci.yml. Not YAML, YML. I don't know why. It's not standard. You'll have to ask GitLab. Actually, now that I think about it, you can go into settings and specify if you want YAML. So I should do that. So here's a very, very simple configuration that runs a job called Plyutil linting. This script is just a one-liner that lintsplists. It lints any plist that it finds in the root directory of your repository. That may not scale completely, but I'm using it as a very simple example. To really kick the tires, we've got to add some plists. So here, for those of you who are not familiar with plists, this is a plist. Exciting. I joke. You're all familiar with plists. This just has a name and a value, but it is a valid plist. So to really get exciting, we're going to have to throw some bad plists at it. So let's put an unescaped less than character in. That's one of my favorite mistakes to make. And how about 2 keys, 1 value? And how about str instead of string? We'll throw all 3 of those at it. Those are all things I've done. Yep, sorry. Truth comes out. When we commit those mistakes to our repository, assuming they haven't been caught by some pre-commit hook we've set up, and it gets pushed to our remote, the CI takes over and it does plyutil star.plist on your repository. And you can see the result of that. It found 3 bad files and the other one was okay. And so it failed. That failure, the failure doesn't mean anything right now because we haven't told it what to do when those things fail. But it's just kind of useful information. You'll see a little red X, a little box that says failed. That's good visual information, but it's not enforceable yet. So to enforce, by preventing merges if pipelines fail, that's where the peer review really comes in. That's where the protected master branch becomes really sacred. So I'll show you how to do that. If you go into your GitLab settings, click on General, and then expand the section that says Merge Requests. There's a wonderful, glorious checkbox at the bottom that should almost always be checked that says only allow merge requests to be merged if the pipeline succeeds. This is the box that's going to put the rubber to the road, that's going to make sure that your pipelines have to pass in order to merge to master. So we're going to check that box and click Save Changes, and don't look back. Now go back to the general settings again, and we're going to click the Expand box next to Merge Request Approvals, and add the people you want to approve here. So you can just start typing somebody's name and then click Add. These are the people on your team that you want to enable the privilege of being reviewers for the code changes that you're going to submit. And then at the bottom, change approvals required to greater than 0. Start with 1. If you have a really big team and you're producing really mission critical stuff, maybe consider more than 1 approval, but most times 1 approval is all you need. And then Save Changes. One more little change we're going to make in the general settings. Click on Repository, and then expand the Protected Branches section. Newer versions of GitLab automatically protect the master branch, but if that's not the case for you, then you may have to manually add, select the branch that says master, and then make sure that the allowed to push option is set to no one. And that means you, as the project owner, are not above the law. And then click the Protect button, and you'll see your master branch appear in the list of protected branches. So what that does to our Git workflow looks like this. When we want to submit a change to our repository, no matter what that repository contains or does, we need to create a branch to hold that change. And we can add the commits that actually contain that change to that new branch. We create a merge request, and we get one of our friendly approvers to give it a thumbs up if it looks good to them. And only then, after it's passed the human check and the pipeline check that's happening automatically, can it be merged to the master branch. So that's fun. The idea of running these tests in the Git remote is kind of a fun, abstract idea, but it doesn't really become a wow thing until you start to think of some of the things you can use it for. So here are some humble suggestions. I would start with anything that would threaten to cause problems or emergencies in production. Anything like, for example, a plist file that has bad syntax could potentially cause all of the values of that file to fail to be read. And if that is a configuration profile that manages some crucial setting, that's a bad thing. So linting those plists would prevent situations like that. I would say also things that are best done in the cloud, that are less efficient when done locally on every person's computer, better done centrally or with cloud computing power. Things like, if you're managing a monkey repository, make catalogs. You could have each person make the catalogs locally, include that in the Git repo, and then commit it up. But there's really no reason to do that. You've got that processing power available to you in the cloud, and that's kind of the last mile before the repository goes to production. So why not build the catalogs automatically when things merge into master? I'll show you how. We do that. And syncing to cloud storage. That's a classic use of CI with GitLab. If you have your monkey repository in GitLab, when you merge changes to master, you can actually take that repository and sync it out to your cloud storage, whether that's GCS or Amazon S3. You can make it actually happen, put it into production, have your Mac clients start seeing the change that you've made. Additionally, anything that requires elevated access or permissions, by centralizing important keys in the pipeline rather than on all the developers' computers, they're much more easily managed and secured and locked down. And especially when you're talking about things like AWS keys and access secrets, you want to make sure the minimum number of people or computers have those as needed. And then get creative, whatever you want. If your team really values a specific thing in terms of code quality, or if you're trying to enforce specific standards on your team, put that into the pipeline and make sure that it passes before anything gets merged. For example, we have a very specific set of categories that we allow in our Monkey repository because we don't want to end up with a situation where there's a category called web browsers and then another one called browsers, just because somebody didn't check first before they submitted their package info file. So we specify that in a Python file. We say, here's the list of categories. If these new package info files don't align with that list, then kick them out. Don't let them merge. And that might be too strict. You might not want to start with something like that. It wouldn't make a lot of friends. But it's useful to think about in the future. Here's some concrete examples of pipeline code that you might want to use. So this is additional duplication. You'll see I'm a fan of redundancy. This is a GitLab pipeline configuration file that also runs pre-commit. Why do we need this? Presumably all of the code that's been pushed to the Git remote has already been through pre-commit, right? Well, no, because pre-commit's not guaranteed to be configured on everyone's computer. It can still be skipped if somebody does no verify when they do a Git commit. So this is where we're actually making those hooks enforceable. All these hooks are going to be run again on the remote. And if they don't pass, the pipeline fails and the branch can't be merged. So this is where it actually counts. If they've already been run through on the local computer before they've been pushed, then no skin off anybody's back and everything's fine. Here's a little bit more complex example. Here's all the tests that well, not all. This is a very select portion of the tests that we're running on our Monkey repository in GitLab. It's obvious things like lintingplists, checking the categories, like I had mentioned earlier, ensuring the icon file is present, but also some very organizational specific stuff. For example, we have a rule that says if you're going to submit a package installer to Monkey, something that ends in PKG instead of like a disk image, it has to have a blocking applications list. Now that list can be empty. That's okay. But it has to have that list. It just shows to us that you've already thought through what applications can't be running when this update gets installed. And so here's how we might set up something like that. For plist linting, it's pretty easy. We can start from the plutil lint plist. Our Monkey repository isn't set up with the plist in the root directory, obviously. So we would need to do something like this. Package info /star for all the different subfolders in there, /star.plist. And then another line, you can just prefix each line with a dash. That's the list in YAML. Another line that says plutil lint manifests /star. And for the more complex checks, we have to kind of reference an external script. So rather than putting every line of the script in this YAML file, we're going to use a separate script and put everything in there, and then have the script return exit code 1 or exit code 0 if we choose. So let's take a look at that script. I've stored it at ci/monkey_linting.py. But before we do that, I have to give you a disclaimer. This script has been stupidly simplified. It's just the bare bones skeleton of what we actually use. And so there's some kind of bad code in here. But it's easy to explain, so that's why I'm using it here. But if you're going to use something like this in production, you may want to add some good stuff to it first. For example, the first thing we do is we make a list of files that we want to check. For this, I'm just using glob because it's one line. If your repository is a little bit more complex, you may want to use os.walk or something a little bit more resilient. But this is just a way to collect all the files that we want to run through checks. Then for each file in those files that we found, we parse the plist. And we're just using plist lib.readplist for that. Now, again, in production, you would want to add a try except around this to make sure that you catch any errors that come up from the linting. or from the parsing. After we've loaded each file, then we can run our checks. And this is where the real action happens. You can build in whatever you want. All the things that you're checking here, just use a block for each check that you want to run. Or if you want to get fancy, you can use a function and call up to that function from the main function. Here, what we're checking for is if there is an uninstall script present in the package info file, but the uninstall method is not set to uninstall script, then some wires probably got crossed. And we want to throw an error and let people know about that before we continue. And finally, at the bottom, we're exiting with whatever the exit code is. Now, notice at the top, we set the exit code to 0, innocent until proven guilty. As we run through the files, if we find any of those issues that we want to stop the pipeline for, then we set the exit code to 1. And at the bottom, we exit with that code. So returning to our CI config, we've now got a Python file in our repo, so you know what that means. Python black again. We're going to add a script to our config file that just runs Python black on the whole repository. So if we make any changes to that linting file that's actually also included in the repo itself, that linting file also has to pass Python black before it can get committed. Inception. So now, a little bit of extra detail here in the GitLab CI. The GitLab CI configuration is well documented, and there's a whole page that lists all the references and all the stuff that you can put into it, and I recommend you take a look at it. But just a couple quick things, because I'm running out of time. The tags tag a specific runner. So if you have a script that requires macOS, you have to use that tag that's aligned with your macOS runner. Otherwise, it's going to use the first available runner that it finds. If you only have one runner, then no big deal. The other scripts that we have at the bottom there, the monkey linting and the black format, don't require macOS. They can run on any runner available. And here's the make catalogs build. It's dead simple. It's just calling the make catalogs binary. And the working directory is always the repo for GitLab. So you just literally have to call make catalogs, and that will run against your current directory. And we only want that to run on the master branch because that's when everything's been linted and approved and peer-reviewed and everything's good. And here is what I kind of casually mentioned earlier. Here's the actual code to make it happen. This would synchronize your repository's master branch with Amazon S3. This was a pretty cool discovery when I finally got it working. You can specify the name of the bucket at the top and then use that in a variable below. And this just causes all that to happen automatically every time you merge something to master, which is a great feeling. So going back and reviewing the Git remote pipeline, we've got code inspection in the form of linting scripts, either built in to the YAML file or references to custom scripts that we've created on our own that exit 1 or exit 0. We've got product builds in the form of make catalogs. And we've got syncing to prod in the form of AWS S3 sync. So that's a pretty good pipeline for a monkey repo. I'm going to have to skip a little bit, unfortunately. I bit off more than I could chew. But I know I've thrown a lot of data at you, a lot of config files, a lot of text on the screen, but I just want to review the core concepts. Mac admins are becoming software developers. There's no avoiding it. And the overlap is called DevOps and includes many tools that can be very useful for us. Some of the ground rules that I follow and that support some of the tools that I talked about are above here. And they give us every available opportunity to catch issues before they end up affecting production systems. And the first tool I talked about is Linters, so you can see real-time feedback as you create scripts, and they help you audit and improve existing scripts. Next tool is pre-commit, a very versatile framework for running tests before allowing commits to proceed. And then when our code is pushed up to our Git remote, it undergoes additional checks using the third tool, CI/CD pipelines. A merge request or pull request triggers peer review and the pipeline checks, where another pair of eyes can review for any issues that humans can find that computers would miss. And finally, after everything's good, can be merged to master, where the CI/CD pipeline can build any resulting products, packages, or profiles, and deploy your code to production, where it will live out the rest of its issue-free, reliable, and beautifully formatted life. The end. So thank you, everybody. I was hoping for time for questions. Unfortunately, I talked too much. But I will be in the hallway. If anybody has questions, I would be happy to talk your ear off. Thank you.